Now it is from 2005 AIPMT. A very long straight wire carries a current I. At the instant when a charge Q at point P has velocity V as shown, the force on the charge is. We know that if Q charge is moving in a magnetic field, what is the direction of magnetic field? It will experience a force. First we have to find the direction of magnetic field. See, it is the conductor. Current is in this direction. Right hand I am using my. It means at the point where charge is, magnetic field's direction is inward. So at this point, direction of magnetic field is inward. This. And it is V. And we know that the direction of force is the direction of V cross B. Inward means negative Z axis. Inward means negative Z axis. So in place of V, and V is the positive X axis, means direction of V is I cross. And direction of B, magnetic field, is inward, means minus K. Remember always in vectors, if you want to know ki I cross J, what you will get, make a circle and put in anti-clockwise direction I, J and K. If you are moving in anti-clockwise direction, product of any two will give you third. But if direction is reversed, it will give negative of third. It means I cross J, K, J cross K, I, K cross I, J. But if you move in opposite direction, I cross K minus J, K cross J minus I, J cross I minus K. So I cross K, it will give you minus J. So minus of minus J means plus J. So what direction we are getting? Positive direction of y-axis. So it will move along OY. So we are going with option D. We are going with option D. Whole was this whole solution was a game of only directions. Next. A closed loop PQRS carrying a current is placed in a uniform magnetic field. If the magnetic forces on segments PS, SR, RQ are F1, F2 and F3 respectively and are in the plane of the paper along the directions shown, the force on the segment QP is. Definitely it will also in the direction of plane. Suppose force on this is this. I am making the force this. I am giving this name F4. So I am going to resolve this F force in two directions. It is, if this angle is theta, it should be F force cos theta. We know resolution of forces in perpendicular direction, it will be F4 sin theta. What is F4 sin theta? It is balancing F2. So F4 sin theta should be equal to F2 because the loop is not moving anywhere. Forces should be balanced. What force is in this direction? it is F1 minus F3 or F3 minus F1. Anyone you can take. F1 and F3 are in his opposite direction. So in that direction, opposite to F4 cos theta is F3 minus F1. It is balanced by F4 cos theta. F2 is balanced by F4 sin theta. We want to calculate F4 by squaring and adding F4 sin theta. What we are getting plus F4 cos theta. We are getting F2 square plus F3 minus F1 square. Take F4 square common. What you will get? Sin square theta plus cos square theta is 1. So we got this F3 minus F1 whole square plus F2 square. So now easy to calculate F4. What is F4? F4 is square root of, what is F4? F4 is square root of F3 minus F1 square plus F2 square. So we are going with D. 23rd. Two equal electric currents are flowing perpendicular to each other, as shown in the figure AB and CD. Where do we expect the resultant magnetic field to be 0? See, AB and CD both are bisectors. Means if you are assuming horizontal direction x-axis, vertical y-axis, on AB and CD, points are equidistant from both the currents. All points are equidistant because they are on bisectors. See on AB, what is happening there? Due to this, current direction is this, magnetic field is outward the page. But due to that, it is inward. Magnetic fields are in opposite direction. But on CD, you can check it will be on same direction. They cannot cancel. So on AB, choose any point. Both magnetic fields are since in equal in magnitude and opposite in direction, so they will cancel each other. So on AB, you can expect the magnetic field 0, so we are going with B. Again only the game of directions. Next, it is from 1996 AIPMT. The magnetic field dB due to a small current element dl at a distance r, current carrying is I, again direct problem of Biot-Savart law, mu naught upon 4 pi I dl sin theta by r square. So dl sin theta means dl cross r. For direction, if you are using r, we have to multiply numerator and denominator by r, so it will become r cube. So we are going with B, because when you will write it dl, it is r sin theta, r will cancel 1 r, so dl sin theta upon r square. Next, it is from 1998 AIPMT. A coil of 1 turn is made of a wire of certain length and then from the same length a coil of 2 turns is made. If the same current is passed in both the cases, then the ratio of magnetic induction at their centers will be, we know that. What is the formula for magnetic induction? Mu naught Ni by 2R. In first case, number of turns was 1. And what was the radius? If length of wire was L, you turn this wire in a circular shape. If radius is R, R means 2R means L upon pi, L upon pi. What will happen in second case? We make 2 turns, mu naught N. Same current is there. What we should put? Now we will make with same length. 2 turns means total circumference is now 4 pi R. So R dash should be L upon 4 pi, L upon 4 pi. Cancel this 2 with this 2. Cancel this 2 with this 2. What we are getting in B2? 4 extra what you were getting in B1, mu naught I pi by L. So B2 is 4 times the B1. So it means the ratio of magnetic induction B1 by B2, first what we were getting and what now we are getting is 1:4. So we will go with option B, 25th B. Next, it is from 1999 AIPMT. Magnetic field intensity at the center of coil of 50 turns radius, direct problem. All physical quantities are given. What you need? Magnetic field means mu naught Ni by 2R. What is the value of mu naught? 4 pi into 10 to the power minus 7. Number of turns 50. Current 2 ampere. Radius 0.5. All are in SI unit. So we will get Tesla. 2 into 0.5 is 1. So what we are getting? 4 pi into 50 into 200 minus 7 into 100 means 10 to the power minus 5. What is 4 pi? 4 into 3.14 into 10 to the power minus 5 Tesla. Write it 1.256 10 to the power minus 4 Tesla. So we will go with B option. Next, 27th, 1999. If a long hollow copper pipe carries a current, then produced magnetic field will be, we know that the produced magnetic field will be only outside the pipe, because inside no field is there, hollow conductor. So we will go only outside the pipe only. So we are going with B. 28th, a straight wire, it is 2 times they asked, 97 and then 1999. So important concept it is, a straight wire of diameter 0.5 millimeter carrying a current of 1 ampere is replaced by the another wire of 1 millimeter diameter carrying the same current, the strength of magnetic field far away is. First, we will make the formula in terms of given physical quantities. What is the formula of magnetic field due to a straight wire current carrying conductor? Mu naught upon 4 pi two I upon distance. At what distance you want to calculate magnetic field? What was in primary case B1? Mu naught upon 4 pi is constant. A straight wire of diameter, no rule of diameter, it is a distance of the point carrying a current of 1 ampere, so 2 into 1. Distance is d. In both cases, they are only changing the diameter of wire, and in formula there is no role of diameter. It depends upon only current and distance of the point. So no change should be there. So what we are going with D only. So 28th D. The 29th problem, it is from 1999. It is from 1999 AIPMT. What is the problem? A magnetic field due to 0.1 ampere current flowing through a circular coil of radius 0.1 meter, 1000 turns. A direct problem. All physical quantities are in SI units, so no need to convert. Only you should know the formula of magnetic field. What is the formula for circular coil at center? Mu naught Ni by 2R. What is mu naught? 4 pi into 10 to the power minus 7. Number of turns 1000. What is current? 0.1 ampere. What is radius? Again 0.1 meter. Cancel 0.1 with 0.1. 2 with this 4. 2. So numbers are also very easy. 2 pi means 6.28. 10 to the power minus 4 Tesla. So we are going with C. 2001 APMT. If number of turns, area and current through a coil is given by N, A and I, then its magnetic moment will be. What is the magnetic moment's formula? It is direct formula, N into I into A. You know that when electron is revolving in an orbit, it is producing magnetic field, and formula is NIA. So direct formula they were asking, so we are going with A. The magnetic field of given length of wire for single turn of coil at the center B, then its value for 2 turns coil for the same wire is. Again, we have to write first formula and which physical quantities are affected in second case. We will go for that. Current in both cases same. Only number of turns and radius we are changing. What we were doing in first case, the given length is used to make 1 turn of a coil, means L is used to make 2 pi R. So R was L upon 2 pi, or 2R was L by pi. So initial magnetic field, it was mu naught number of turn was 1, I means I, 2R means L by pi. What happened in second case? Same wire we used to make 2 turns. Now circumference will be 4 pi r. So now radius of coil will change and it will become L upon 4 pi. What magnetic field now you will get at center? Mu naught. 2 turns are there. Current is same. 2R, but R is now L by 4 pi. You are getting this number. Cancel 2 with 2. So what we are getting now means they want to know BF in terms of BI. Mu naught was in both cases. I was also there. Pi was also there. L was also there. What additional we are getting? 4. So it should be 4 times the initial value. So we are going with C, 31st C. Next, it is from 1990 AIPMT. The magnetic induction at a point P, which is at a distance of 4 cm from a long current carrying wire, is 10 to the power minus 3 Tesla. The field of induction at a distance 12 cm from the center will be C. You know the formula. At a distance d from a wire, magnetic field is given by 2I by d. Initially they are saying magnetic field is 10 to the power minus 3 Tesla. When distance was 4 cm, but now we want to know magnetic field. We make the distance 12 cm. Means we triple the length, take 3 outside. What you are getting? Mu naught upon 4 pi. 2I by 4 into 10 to the power minus 3. And you know the value of this? 10 to the power minus 3. So now we are getting 1 by 3 into 10 to the power minus 3 Tesla. Initially it was also Tesla. Take, multiply and divide with 110. So you will get 10 by 3, and by dividing you will make it 10 to the power minus 4 Tesla. So what we are getting? 3.33 into 10 to the power minus 4 Tesla. So correct answer should be A. It is from 1992 AIPMT. The magnetic field at a distance r from a long wire carrying conductor I is 0.4 Tesla. The magnetic field at a distance 2r is, just we saw that in case of wire, magnetic field is inversely proportional to r. It means by doubling the distance you are making magnetic field half. What we are saying? In a wire, product of B and distance should be equal, constant. If initially it was 0.4 Tesla, distance was r. Now distance is 2r. So it should be half of the previous value, means it should be now 0.2 Tesla. So we are going with A. 2003 AIPMT. A long solenoid carrying a conductor produces a magnetic field B along its axis. If the current is doubled and the number of turns per centimeter is halved, the new value of the magnetic field is, you know that what is the formula for solenoid? Magnetic field on axis is given by mu naught Ni. Mu naught Ni. N is number of turns per unit length. What we are doing? Initially it was, what happened now? We were doubling the, if the current is doubled, in place of I we are putting 2I, and number of turns per unit length is halved. 2 is cancelled with this 2. It means there should be no change in magnetic field. What it was previously, we are getting same. So we are going with B option. So 34th, B option. 35th problem. Two parallel wires in free space are 10 centimeter apart. Each carries a current of 10 ampere in the same direction. Same direction, just we proved in previous slides, if currents are in same direction, wire will attract each other. If they are in opposite direction, they will repel each other. So either A option is correct or C option is correct. By what amount? We calculated that force per unit length it was mu naught upon 4 pi 2 I1 I2 by R, means distance or D. So what we are getting here? Mu naught upon 4 pi 10 to the power minus 7 2 I1 I2, current in each wire is 10. Distance between them is 10 centimeter. We are doing in SI units, 1 upon 10 meter. So we are getting 2 into 10 to the power minus 7, 10, 10. Take this 10 in numerator. What we are getting? 2 into 10 to the power minus 4 Newton. So which one is correct? A. 2 into 10 to the power minus 4 Newton. Next is from 1998 AIPMT. Two long parallel wires are at a distance 1 meter. Both of them carry 1 ampere of current. The force of attraction per unit length is, again direct formula. What is the formula? Mu naught upon 4 pi 2 I1 I2 upon distance between the wires. It is 10 to the power minus 7. Both of them carry 1 current. It is force per unit length. And we want to calculate this only. Distance between the wires is 1 meter. So direct we are getting 2 into 10 to the power minus 7. Force per unit length means Newton per meter. So we are going with C. Next. It is from 1988 AIPMT. A current carrying coil is subjected to a uniform magnetic field. The coil will orient so that its plane becomes, we have a derivation, I explain you in the case of galvanometer. If we put the coil in this way, one force was acting on this and on this. They want to try to make it perpendicular to magnetic field. So we will go with option D. 1993 AIPMT. A coil carrying electric current is placed in uniform magnetic field. What will happen? Again same type of problem we discussed there. If we are putting this in a uniform magnetic field, the two arms of the coil will experience a force in opposite direction and they will form a torque. They will form a torque. So what we are going with? We are going with A. If field is non-uniform, then we will go for torque and force, otherwise torque. Next, it is from 1994 AIPMT. Area of coil is given. The circular loop of area 0.01 meter square carrying a current of 10 ampere held perpendicular to magnetic field of intensity 0.1 T. The torque acting on the loop is, we calculated there कि two equal forces, see, we put the wire coil like this. In both wire, since direction of current is opposite, so both wire will experience a force I, L, B. I explained you at there if length is L. If current in this wire is going in upward direction, in this that is going in downward direction, if one force is inward, other should be outward. So they will make a torque. Torque means one of the force into distance between the both forces. So it means that torque will become IBA. I is given 10 ampere. Magnetic field is given 0.1 Tesla. Area is given 0.01. Unit of torque is Newton meter as a unit. So 10 into 0.1 means 1. So what we are getting? 0.01 Newton meter. So we are going with B option. Next, it is from 1992 AIPMT to convert a galvanometer into a meter. We discussed in theory sheets before starting this crash course. Means this unit. If you want to convert galvanometer into a meter, you need one shunt, a low resistance wire, which we will connect in parallel. If you want to convert galvanometer into voltmeter, you need a high resistance wire and you have to connect this wire with series in galvanometer. So now we need a low resistance in parallel. So we will go with option B. Next, it is from 1998 AIPMT. A galvanometer having a resistance of 9 ohm is shunted by a wire of resistance 2 ohm. If the total current is 1 ampere, the part of it passing through the shunt means you want to calculate I minus Ig. We know the formula S is equals to Ig into G upon I minus Ig. So what is the value of I minus Ig? It is Ig into G divided by S. But total current is given. It means I plus Ig is given. Galvanometer's resistance is given. What is given? G is given 9 ohm. Shunt is given 2 ohm. total current I is given 1 ampere. So what we can calculate in this? We can calculate Ig. We are putting the value in this. So what we are getting? S means 2. Ig into G. G means 9. I means 1 minus Ig. Means we are getting 2 minus 2 Ig, and it is 9. G, it is given 9. So 2 minus 2 Ig is equals to 9 Ig. So 11 Ig is equals to 2. So Ig is equals to 2 by 11. So now I minus Ig we are capable to calculate. 1 minus 2 by 11, it means 9 by 11 means 0.8. So we have to go with B option. Next, it is from 2001 AIPMT. Tangent galvanometer is used to measure current. We discussed there, with the help of theta you can calculate the strength of current. To convert a galvanometer into a voltmeter, we have to connect one high resistance in series with galvanometer. So high resistance in series with galvanometer. Next, 2004 AIPMT. A galvanometer of 50 ohm resistance has 25 divisions. A current of 4 into 10 to the power minus 4 ampere gives a deflection of 1 division. It means for 50 division we need, which we say Ig, a current of 50 into 4 into 10 to the power minus 4 ampere. To convert this galvanometer into voltmeter having a range of 25 volt, V is given 25. What resistance should be connected there? We know that what is R? V upon Ig minus G. Galvanometer resistance is given 50 ohm. So what is V? V is 25 upon Ig, 50 into 4 into 10 to the power minus 4. Minus G means 50. Take minus 4 in the numerator. So we got the value of R, 25 into 10 to the power 4. 50 into 4 minus 50. 25 twos are 4 into 2 8. It is 10,000 divided by 8 minus 50. 8 twos are 8 ones are 8, 20. 8 twos are 16. 1250. So what we are getting? It is 50 into 50 ohm resistance. G was given 50 ohm. Has 25 divisions. Not 50. It has 25 divisions. So current we need for full scale deflection 25 into 4. It is 25 into 4, not 50. It is 25. It is not 50. So it should be 25. So cancel this 25 with 25. So now what we are getting? We are getting R is equals to, take 10 to the power 4 in numerator by 4 minus 50. 10,000 upon 4, 2,500 minus 50. So we are getting 2,450 ohm. So 2,450 ohm in series. 2007 AIPMT. The resistance of an ammeter is 13 ohm and a scale is graduated for a current up to 100 ampere. Additional shunt to become it 750 ampere ammeter. It means now 13 ohm will play the role of resistance of galvanometer. Ig is now 100 ampere. You want to measure current up to 750, you need a shunt. What is the value of shunt? Ig into G by I minus Ig. So what is Ig? 100. G 13. 750 minus 100, 650. So what we are getting? 100 upon 50, it means 2 ohm. So we are going with A option. So in this way, we have completed all our assignment of related to magnetic effect of current. Thank you.